Hello and welcome to Math Made Easy by Mrs. Roberts. This is going to be episode 2 in a little mini series I'd like to call Trig Integrals. So in this video we are going to do an example where the power of sine is odd and positive. And so in this example I want us to find the integral of sine cubed x times cosine fourth power of x dx. So we have to think about a couple of different things here. I see that I have a sine times a cosine, and I have an odd and an even power here. So can I get things mostly in terms of sine or in terms of cosine? And if I do that, will I have a derivative in there somewhere? And so I'm asking that because when we're finding the integral, we want both a u and a du. So um, I would say that maybe our u would be cosine of x. So maybe our u here would be cosine of x. And if cosine of x is our u, then our du would have to be negative sine of x dx. So what that tells me is that I want one sine of x left in that integral. So are there any trig identities that I can use to help me so that I only have one sine of x left so that I can identify a u and a du and then use a power rule? So let's see here. If I only want one sine of x, I could rewrite this as the integral of sine of x times sine squared of x times cosine to the fourth power of x dx. Okay. Now, this sine of x, we're saving. We're saving that sine of x to end up ultimately being our du. Well, if that's the case, I want to get everything else in terms of cosine. Is there any way I can do that? Bingo! Let's use one of these. Okay, so this first Pythagorean identity says sine squared of x plus cosine squared of x equals 1, which means that sine squared of x equals cosine or equals 1 minus cosine squared of x. And so I can replace this here with 1 minus cosine squared of x. Let's try that out. So that means I'm going to have the integral of, let's put our du in blue so that we know don't mess with this guy. So sine of x is going to be our du. I'll put what I replaced in this rainbow pen so that you know what I just changed. And I changed that by using a Pythagorean identity. And then I'll go back to the black pen and I'll write the stuff I didn't change. Well, this is still pretty ugly. How the heck do I take the integral of this? Well, this is still reserved. This is still reserved. We aren't going to mess with that guy. But let's distribute this in. Let's distribute this like that. And so we're going to have the integral. And again, I'm going to leave this sine of x in blue, and I don't want to mess with it just yet. And what I'm going to change, I'll put in the rainbow pen. So we have sine of x times cosine to the fourth power of x minus cosine to the sixth power of x dx. All I did was I distributed in that cosine to the fourth power of x. If I distribute in that sine of x now, then both cosine 4 to the x and cosine 6 to the x have a sine of x with it. So if I distribute in that sine of x now, then I'm going to have cosine to the fourth power of x times sine of x dx minus cosine to the sixth power of x sine of x dx. But how did that help? This looks just as ugly as it did before. It actually isn't, because now what I could do is I could assign a u, and we already know what du is, for both of these integrals and then integrate. And so over here, oh, I lost my pen. Stick with me here. Sorry. Okay, so over here, I could say that my u is cosine of x, which would make my du negative sine of x, which would make this entire integral right here the negative integral of u to the fourth power du. What? What just happened? So this piece of it right here is my u. My u. And this piece of it right here is my du. And what I was missing was the negative out front of sine, and so I just put it out front. And now I can integrate this. I can integrate this, and this is going to be increase the exponent by 1 and divide by that. This is going to be 1/5 u to the fifth. And I have to replace my u. So this is 1/5 cosine to the fifth of x. Wow. Wow. We can do the same thing here. We would say that cosine is our u. Our du would have to be negative sine of x. Well, a negative and a negative makes a positive, so these are going to now be added together. We are going to integrate u to the sixth du, and where those come from is my du is here. My du is here. My du is here. My u is the cosine of x piece of it. Cosine. My u is here. And now we just integrate by increasing by an exponent and dividing by that new exponent. And don't forget to add the plus c. Yeah, that was insane. Let's do a little recap, okay? So we started with the integral of sine cubed x cosine to the fourth of x dx. Now, I needed to set aside one sign, because that one sign was going to be the du of cosine. How did I pick that sine was going to be the du? Well, it was the odd exponent. The one with the odd exponent is the one that you're going to make your du, because that's the one that you can evenly split the other thing into the Pythagorean theorem. Okay? Then, after I figured out my du, I was able to use a Pythagorean identity and get everything in terms of cosine. I did some crazy algebra here, and I split it into two integrals. Then I did u substitution, and I applied the power rule. And there is our equation. Okay, I have an example for you to try, and that's where I'm going to part this video. I'm actually not going to work it out. I want you to try it out. And then if you have questions, you can drop them in the comments below, or during our live session, you can ask then. So my challenge to you is find the integral of sine to the fifth power of x times cosine squared of x dx. And my hint, my helpful hint, let's see, hint, use the odd trig function for your u. You just want to set aside 1. All right, I hope to see you in episode 3.